Hello students. Today we'll be learning about the angle of elevation and depression by using our trig functions. Let's do the warm-up together. Question 1 says to solve for x. So first we need to write down SOHCAHTOA so we remember the different trig ratios. So when I look at 15 degrees here, I see that opposite is given, which is x, and the hypotenuse. In SOHCAHTOA, if I have opposite and hypotenuse, I'm going to use sine. So I can write sine of 15 degrees equals opposite x over the hypotenuse, which is 6. Put a 1 on the bottom, and we can cross multiply to solve for x. So I get x equals 6 sine 15. Using the calculator, we can just type in 6 times the sine of 15. Typing that in, we get x equals 1.55, and I'll just round to 2 decimal places there. So 1.55 as a side length. Next, looking at number 2 on the warm-up, I'm given 20 degrees. This time I'm given x, which is adjacent, and the hypotenuse. So looking at SOHCAHTOA, I need to use the cosine function. So the cosine of 20 equals adjacent, which is x, over the hypotenuse 6. Put a 1 on the bottom and cross multiply. You get x equals 6 times the cosine of 20. Type this into your calculator. So just type in 6 times, click on cosine 20 degrees, and you get 5.64. Which means that this side length is 5.64. The purpose of this lesson is that you should be able to solve problems using angles of elevation and depression. Here's example 1. A building is 50 feet high. At a distance away from the building, an observer noticed that the angle of elevation to the top of the building is 41 degrees. How far is the observer from the base of the building? So now we're putting this into the context of a problem. Always draw a picture for these. So I have a building, and there's an observer standing a distance away. So I'll put the observer standing right here. The building is 50 feet high, so I'll add the side length of 50 here. The observer notices that the angle of elevation to the top is 41 degrees, so as they're looking upward like this, the angle that they're looking at is 41 degrees. It says how far is the observer from the base of the building. So I'm wondering, when I connect here, how far the observer is, so I'll put x. I have a right triangle, so I can use trigonometry to solve this problem. I'm given adjacent and opposite. When you think of SOHCAHTOA, that would be the tangent function. So I can do the tangent of 41 degrees equals opposite 50 over adjacent x. Put a 1 on the bottom and cross multiply. So we get 50 equals x times the tangent of 41. To get the x by itself, you divide by tan 41 on both sides. You end up with x equals 50 divided by the tangent of 41. Go ahead and type this into your calculator. And you should get 57.52. So this means that the observer is standing 57.52 feet away from the building. The next example. If you are 6 feet tall and 100 feet away from the Eiffel Tower, what is the angle of elevation of your line of sight if the tower is 1,063 feet tall? As always, draw a picture first. So we have the Eiffel Tower and a picture of us. So we are 6 feet tall, so we can label ourselves here as 6 feet tall. We're standing 100 feet away from the Eiffel Tower. So we'll stand, so drawing this, we can stand like this, 100 feet away. It's asking what is the angle of elevation of your line of sight if the tower is 1,063 feet tall. So here's the tower, 1,063 feet tall. It's asking the angle of elevation of our sight. So we're trying to find the actual angle measure here. So as we think about this problem, we're given adjacent and opposite again. So we're going to use the tangent of x degrees equals opposite 1063 over adjacent 100. In this case, I'm going to ignore that our height is 6 feet tall, and I'm just going to pretend that we're actually looking from the ground level. If you wanted to include that you're 6 feet tall, you could just subtract 6 feet from 1063 and get our elevation from that point. Because we're trying to find the angle measure, we need to use the tangent inverse function. So in our calculator, we're going to type in second and then the ratio here, 1063 divided by 100. So go ahead and click second tan 1063 divided by 100, 84.62, and I can round that to x equals 84.63 degrees. So from our eyesight, which we're saying is from ground level, would be 84.63 degrees. And notice I put the degree sign there. Those are 2 examples for today. You guys can go ahead and try this U-Try, and I'll see you in class tomorrow.